Hello, everybody. This work is entitled Determination of Electroactive Area in Porous Carbon Materials by cyclic voltammetry using peak current and peak charge methods. This work was made for researchers from Politécnico Colombiano Jaime Sosa Cadavid and Universidad de Colombia, both in Medellin, Colombia. Well, the motivation of this paper is based on the idea that when typically we make calculations for the determination of electroactive area, we use theoretical models that assume that the form in which the electroactive species move onto the surface of the electrode are based on a linear semi-infinite diffusion. But when you have porous materials, uh, this approximation could not be validated, so we need to work in other new methods that could approximate in a better way the real electroactive area. For this research, we start by the obtention of porous carbon materials with a typical method in which we start using pasta grass, then we made their lignification, and then we, by pyrolysis, we obtain carbon porous material. Then, from this carbon porous material, we prepare dispersions in water. We sonicate this system by 5 minutes and obtain a stable dispersion of carbon in water. Then we deposit 4 drops of 5 microliters onto the surface of a glassy carbon electrode and make electrochemical measurements using a typical redox-proof ferroferricyanide. Well, we obtain the area for three methods: the typical London-Simpson equation, in which we construct graphs in which the current peak is graphical versus the square root of the scan rate, and from the slope of this graph we obtain the electroactive area. Here we can see the equation that modulates this method, and then we use the same for obtaining the area from other two methods, calculating the charge from the start of the cyclic voltammetry to the maximum peak of the oxidation, and directly obtain the area from the current peak. This is the equations that we use for make this calculation. We use this methodologies for three different scan rates: 5, 10, and 50 milliwatts per second. We obtain first we obtain the different slopes for the graphs obtained from the last results, and we obtain, for example, a very good correlation between the logarithm of the current measurement by the methods versus the scan rate. But the interesting here, this is the most relevant result of this method, is that when you try to correlate a physical measurement of the area by nitrogen absorption versus the electroactive area measured for random septic or for peak current or for charge, uh, we cannot correlate these results. It implies that both methods, the surface area by bed versus the electrochemical methods, are not are not the same. Uh, the same thing. It explains different things. For this, you can use one for explain, for example, the electroactive activity of some electrochemical measurement. In fact, we try to correlate bed with electroactive area, or for example, the volume of the pore for versus electroactive area, and we can find a well correlation. But the correlation between the electroactive area methods correlates well. It is it is not a surprise, in fact, because all these methods are based in the same theory. Well, for more information, you can write an email to this direction or to this direction. And thank you.